Sense of accomplishment. I mean, put all the sports he does, like good stays.
All right, got everybody within earshot, mostly-ish. I'll give Brian an assist here, maybe. So my name is Chris Meyer. If you have not been to our new building, welcome to the new Sector 67. We're slowly painting it. If anyone wants to help, you're more than welcome to. I think, as far as I know, the only two things to talk about is the wire bender and this crazy-looking spiky ball. Did anybody else bring anything to talk about tonight? That's what I thought. Let's make it up as we go. Nick, at some point, will drag his bicycle over, but he was.
Maybe he'll get it now.
No, it's. It's fine. It's not
There's a basement here?
Exactly. At any rate, we got some fun. So the kind of genesis of this wire bender project was from about 5 years ago. I had two high school students from East High who were part of this middle college program. The middle college program, the idea is that you get students involved in healthcare, IT, and manufacturing tracks. You can imagine a poor high school student who gets stuck working in a factory all summer doing, like, one of the projects I heard about was literally organizing shelves. That was their high school project. So they got these kids to label and barcode shelves and move, like, product that hadn't been touched in 10 years on the shelves to figure out what was there. That seems like not a fun high school project. So the two students that I had, I thought I would let them kind of do whatever they were interested in. So we started off by helping to fix some of the tools and some of the equipment around the shop, and then we decided that we would try to build some kind of an open source machine. So I gave them a few options as the things that I knew about and said, if you guys can come up with something, that's fine too. And we settled in on building this DI wire bender. The idea is, I forget who posted it. Somebody put it up online. I think it was a Kickstarter. They released it open source initially. They then realized that it's hard to fulfill a Kickstarter open source project, as everyone does, and then they've now gone to a closed source machine. These, if you've ever seen a steel rule cover, so you make a steel rule, it's like a bent piece of, it looks like shipping strap, the metal banding, and then you make it really sharp on an edge, and then you route in a trace into a piece of plywood and you glue the steel rule into it, and now you have a stamping machine for cutting like leather or clothing or plastic more commonly, as like a die cutter more or less.
For paper.
And paper, yeah, that's the other big one. So this machine idea comes from those. So those are really common in industry where they'll make these dies with a steel rule, and this is the type of machine that would bend that up. The unique thing with this machine, which is more similar to like a spring maker, is that you can run round stock through it instead of flat stock. And so you've got some possibilities of different interesting things, interesting shapes you can make. The thing that I saw that was most appealing is in some of their newer videos. That one that I sent out to the email list with a meeting announcement was basically this machine running, and they made some glasses and some other things and a lot of 2D type shapes. But the kind of cool thing is you can make a 2D profile and you can assemble them into a 3D shape. So, it's working, maybe. It's got, the software on it is pretty terrible, like really terrible. I can't account for a lot of things that they're doing. And one of the bugs, it seems to be that right now if you run it and you have too sharp of a bend, it just stops doing anything. It'll like feed up till it gets to too sharp of a bend, and then it just doesn't do anything. And it doesn't have any checking ahead of time before it sends all the commands and does it. A couple other interesting things I found. The max memory on the Arduino that they allocated in their array is 255 numbers. And they send 233 zeros in their stock software, and then they send your commands. So if you have more than 20 commands, it overruns the memory and then it just fails. I don't know if they did that on purpose or if that was just like whatever the version they released just ended up screwing up and that's what they put out. But nonetheless, that was the first thing that I had to find and fix because it just kept going array out of bounds every time you tried to send any file at all. Because all the files are more than 20 bends. So once I fixed that, now it seems to work decently, but every time you try to change the program that you send, you have to turn off all the power supplies, unplug the Arduino, close processing, relaunch processing, plug everything back in, and then it'll take a new program. So that's the other one bug. I think they're not clearing the serial port or something like that. I'm not really sure what's going on with that. So if anyone's interested in poking at the software side of it, it could use some love in that regard. The other thing is there's no, even though it's hooked up to the computer, they didn't put any debug anything in. So you can't manually command anything to move to like check to see is it bend or does it move or is it moving a consistent distance or any of those things that would all be logical to be able to test aren't in there. So yeah, Dennis?
Is yours 2D only? Because in the video it also showed like the ability to twist or something.
I always gotta be that guy who just,
Wow.
while you're down. Yes, so right now Joe is the 3D third axis. Joe, if you want to give a demo there, you can. So, yep, there we go. 20, oh, there you go, 28 degrees. Perfect. So we'll do that for now. So yeah, the rotary axis right now, the step ratio is on. So the stepper motor is moving, but it's only moving like 5 degrees, even if you command 130 degrees. And so I have to go into the Arduino code to reprogram the number of steps per commanded unit. But other than that, yes, it's conceptually there, and I think that's like the smallest motor we put on it, but it should be probably one of the bigger motors. What we're probably going to do is just counterweight the head so that it's neutral, so that as it's rotating, it's not trying to rotate this huge mass. To give a little bit more backstory, the reason it looks the way it does and the reason it's configured the way it is, we built it originally, and I bought those like $10 stepper motor drivers on eBay, which you should never buy. They don't work. They physically don't function. And so we later found a website that talks about all the hundreds and myriads of ways of why they don't work at all. They're totally built wrong. The drivers don't have any power, all kinds of things. So consequently, we were trying to debug why it wouldn't bend well, but we figured we didn't have enough power. So we just put a bigger motor on it to make enough power, and then put a giant gear reduction on it, and it's got plenty of power now, only because we swapped out the stepper motor drivers. So my students from the middle college program 5 years ago built the machine, got it working. They iterated from laser cut pieces up through 3D printed pieces, up through aluminum pieces, up through giant motors, and then still couldn't figure out why it didn't work. They then graduated, they're in college now and are probably almost done with college, scarily enough. But I now have a couple of new high school students who are here and are asking if they could help with something, and I said we should see if we can resurrect this thing and make it go. So they've been working the past 3 weeks, 1 day a week on getting the new stepper motor drivers installed and getting it working. So it's now to the point where it's mostly working and needs calibration and debugging and software fixing probably.
Are they on the list, those students?
On the list.
From 5 years ago.
Oh.
So could they be watching right now?
They might be watching right now. I don't know if Barrett or Stray are out there, but they might be. I know Barrett is around periodically. I have not seen a Stray in a while. So, but yeah, they may be aware that we are go-guarding their creation. Yes.
In watching the video, when it made a smooth curve like this one just did, it kind of does the extrude bend, extrude bend, extrude bend. Does anybody who understands materials know, could you just sort of hold that thing against the wire as it pushes out?
The reason they don't do it on this one is it doesn't have the right drive mechanic. So you need a trapped, like right now we have a piece of 1/2-inch copper piping, and that aluminum wire just stacks up when you try to push it. So you need like a MIG welding guide tube. But if you do a guide tube, then you're fixed on your wire sizes. So if we want to, like, say we're only running 16 gauge aluminum electric fence wire, that's all we're going to do. We could totally sleeve it, and then you'd be able to shove really hard and trap that pinch drive. And then, yeah, you can put the bend head in the way of it and just run into it. That's how they make springs. So they'll pitch it at an angle, plow the material in, and it just spins on the way out. And they'll also integrate a cutoff tool. So as it finishes, it comes up, cleaves the metal off, and it starts a new one. And there are factories that have machines just like this, and that's what they do all day long, is they make custom springs. And that works out pretty well for them, I suppose. Because the material's cheap, and springs are expensive if you need a custom one. So, but yeah, that would be, right now, as somebody pointed out a few minutes ago, the front screws are loose on the motor, the laser cut stack up of pieces allows the solenoid completely to float. And it works, it's functional, but there's a lot of things that need to be constrained better. The other thing is the bend pin can only move about 60 degrees because the arc on the aluminum plate doesn't match the arc on the gear, which is back to my high school students learning about radii and things. So, but again, it's functional and it works, and it's sort of a proof of principle to kind of play around with it and see what we want to do with it. Which brings up the next point, which is what the hell do we want to do with it? It's cool, it moves, it bends things, but we need to come up with some interesting things. The coolest things I saw, like I was saying online, are you use this to generate a 2D profile, and then you stack them into like a globe. You can make really cool lights and light fixtures and things. I know Richard and I talked a little bit about maybe being able to bend up like glass blowing mold, because this would produce a cage, kind of like a bird cage. You could stabilize that in wood, and the glass would have to touch the metal, and that would allow it to form without burning the material. That's up to his expertise more than mine. But at any rate, it might be an interesting way to do interesting profiles, because you could blow into it and then you could probably have this in two halves and pull it apart and pull the piece out. But other than that, I don't know what the potential applications are. I'm happy to, myself as well as the high school students are happy to kind of keep playing around with it. It's a good excuse to learn 3D modeling and geometry and design, and it's sort of an interesting machine that way to work on improving. The other thing is it's not a very fundamentally a very complicated machine, and it's very low risk. Like if you screw something up, it's just going to bind up and the steppers won't step. So that from that perspective, it's a pretty good machine to learn on. There's not a lot of fast spinning parts like a router or a mill or anything else that way. You can still get pinched by it.
Couldn't you put like an STL into it, or can you get a more? I mean, what's the limitation on the design?
Yeah, so the interface that they provided, you can either bring in an SVG, so that's what Charlie's been doing. He's playing around in Corel, drawing an SVG, and then the other interface they showed was Rhino, and I think it's a spline.
Okay.
So Rhino can do like a 3D
spline,
and I'm not sure what format that exports as, or what format they're bringing it as. But my guess is it's some flat geometric, point node, 3 space.
So it's slicing it like you would with a
No, it's like figuring out a node and a vector.
It's a math.
It's a math.
Rhino outputs equations for their.
Oh, it does.
Stuff.
Okay,
Yeah,
so that might be what it is then.
So
I don't know offhand, but I do know there's a 3D example, and we can see what. And they provide a file, so we can look and see what the file is.
So would you need Rhino if you want to do 3D?
I don't know, because I'm not sure what the actual output format is. I do know you can manually you can type in, and what it's ultimately generating is just an array. So it's a distance in the first column, the second column is the bend head angle, and the third column is the rotary head angle. So you also can, I can imagine you can figure out a way to output the array commands. The thing that it is doing is it lets you, within the SVG, as Dennis was asking, you can increase or decrease the number of nodes. So that number of times that it pushes out bends, you can totally change that to make it coarse or fine.
And you could make it smarter than their software, because somebody brought in a model that was really polygonal, and their interface just showed a bunch of dots that were like equally spaced along the path, including not at the vertices. So if you actually told it to bend that, you would end up with like a chamfered corner. And it should be smart and realize like, okay, the vertices have to be at that point, and then you could get away with no bend points for quite some time. And you can optimize where the bends are. Sharper curves need more. So there's a lot you could do on the software side. With a little bit of knowledge of curves and geometry and stuff, you could really rock it.
All that math stuff you tried to
Did you hear nerves? Nerves are a dirty word.
So speaking of
non-uniform rational,
nothing in the software is addressing the potential for collisions with the machine itself,
So
based on the bend.
Well, the machine. So if you look at the professional, real versions of this, that where the two green blocks are nearest the bend head, that is typically a very swept surface.
Yeah.
So that it just sweeps, no matter if it bends on itself, it doesn't matter because it just rides up the.
No, but you could give it a series of bends that would then make the shape come around and collide with the machine.
Oh.
yeah.
And there's nothing in the software that
No,
I'm guessing
who cares?
does.
If the wire just bends, it's fine. It's the best part. It gets out of its own way. But yeah, no, there is no smarts to any of it at all. And like I said, we've done very little in the way of optimizing it. But it is running. Like I said, the next step is to push out a known distance of wire, and then start to measure it to calibrate the number of steps. Because like right now, the push out distance isn't even right. That's the easiest one. The angle of the bend head actually gets complicated because it's if it has to duck, it goes under with the solenoid, goes over, comes back up, and then bends the counter angle. There's some math going on in there that gets a little complicated. So
probably got to calibrate that too, because sharper bends are going to take,
Yeah.
they're going to have some elasticity and things like that.
So I do know on GitHub someone posted kindly that they took all of the open source code and they reorganized it to make it actually make sense, because it's all written out of order, like none of it's organized. It's pretty rough. So I think there's a better copy of it out there. Yeah, these machines are, like I say, they're if you need one or when you need one, you can do cool stuff with it. But beyond that, my only hope for this was that you could bring it to like a festival or a fair or something, and it's relatively cheap and it's quick to make things that take up space, and so you could have some fun making stuff like that versus the 3D printing or the routing or machining or whatever. All
If you can get enameled wire that they wrap motors with, it's
sure.
really beautiful. I used to do people's names that way by hand and give them out as gifts.
Gotcha.
And it's a beautiful kind of wire that catches light really nice.
Cool.
Maybe we can just make some transformers too.
Could do that. We should get
custom key rings.
some. What's the memory or what's the metal that takes a set?
Yeah.
Oh,
Figure
yeah,
that stuff in. So you could do
that-
that. You could bend it out and have it reform to something else. Light now, yeah, that's good. Mark, do you have something?
So what's the, how thick a wire would you put in that right now?
Joe, you want to demo with your finger? I think, I mean, really the stainless steel end,
Use
it
the
just
power?
pulls right out, so you can switch it out. But it like,
I was trying to see how much stress it took to actually override the
Sorry.
motor. Good.
it like you're not. It's
Oh, yeah,
gonna, yeah.
You could maybe do like
It will bend
maybe 1/8
fingers.
inch. Maybe 1/8 inch.
Aluminum?
I had steel. I had steel in there originally. That roll of steel that's right on the table there. I think that 4 gauges. What's the? It's like a new roll. What size is that stuff? 'Cause I was running that. That's pretty decent. Like,
16 gauge.
so 16 gauge. But I think it would bend way thicker. I mean, it's that bend head. That's one of Cormac's drive motors for the metal. That's further gear reduced. I think it would bend a lot of very thick things.
You're more likely to like rip apart this whole laser cut assembly.
that-
Because as I don't know if you guys can see this, but there's already a little bit of slop.
Yeah, there's a lot of
You could have 3D
a lot of
printed.
things. If only we had a mill we could make some metal parts on, we could upgrade this sucker.
Does it account for the spring back?
Yeah, the code seems to be making compensations based on if it ducks under, it's coming back farther than it would otherwise. The other thing is that bend pin really should be a spike, so that it always walks its way to the right. Because occasionally it comes up and it kind of blunts itself in the wire, and it doesn't force itself up and over. So if we made it taller and spikier, that would help to make sure it landed on the correct side when it ducks over.
Could you do like heat a straw and like do the same thing with the straw to make a facility straw? I mean, or something like.
Or facility straw
Again,
assembly factory?
straws are out. We don't use straws anymore. But if you were.
If you were.
A reusable
you do
straw.
glass
There
straw,
we
you do
go.
glass
Let's say get some aluminum tube.
Yeah.
So is there a hard cap on 255 bend points then? I didn't quite catch it. Is it?
No, I think they're allocating an array in Arduino. You could definitely
Okay, but it's-
put additional memory in it, but you're nowhere near the memory limit. So I think, so here's a great example of why the code is terrible. For every time it sends one number, it delays 600 milliseconds, doing nothing. It delays 100 milliseconds per step. And I think they must have had issues communicating with Arduino or something. But right now they're sending a number, and then a 100 millisecond delay, and then another number, and then a 100 millisecond delay, and then another number with a trailing and a heading 100 millisecond delay for every single point. So 255 points times like a couple seconds of heat is bad. And then it's got like a 5-second delay before it starts bending after it's gotten all the commands. I don't know what.
I guess my question was, does it basically download everything in the Arduino?
And then-
okay, so you are limited by
That could be fixed.
But you could completely,
That could be
again, that's
fixed.
like the dumbest thing. Why are you transferring an array of
Yeah,
values
right.
before you start making it work?
And
Just
this all
simulate
got
the old
worked out with
tape
3D
drives.
printers. The early 3D printers had communication stupidity as well, but now it's all worked out.
Yeah. And this thing could be right for an up. I mean, there's no reason this isn't just a 3D printer. Like, there's no reason at all that the
Yep.
stepper motors aren't just looked at as a 3D printer. And the only complicated code is the duck. But again, that could be easily remedied. So
That's just a tool head.
yeah. No, yeah, exactly. Swap the tool to location. So yeah, it's something where it was made when this stuff was still a little more complicated and not as thought out as it is now. And the drives and stuff are a lot easier. So, but again, we need fun applications before we optimize the hell out of it. That would be the funny thing. Because the other thing too is it moves so slowly. There's no reason at all that it runs as slow as it does. It should be able to zip wire out.
I think you put it right next to the balloon guy at the carnival and just compete with him.
Yeah.
Actually, you sharpen the wire.
Big little animals. There you go. Big little Teslas.
You could put a sharpener at the end of it. You know, it just grinds the tip of it
Or
real
make
quick.
the cutter diagonal, like, so you always end up with a sharp pointy bit.
Just sell those points.
I guess the bigger question is, can you track a balloon and bend the wire as it comes out?
As it goes out to hit the balloon. There we
You
go.
just- you
You
gotta
already
sell-
said.
sell
He said,
little-
can you track the balloon and then bend the wire to hit the balloon wherever it is? Rather than the machine. Do a little machine vision while we're at it.
You can custom car unlocking tools.
Oh, locked out.
Type
We'll
in
stop
over
the
your
wire
car
bar
and
and it
it-
just bends in.
Oh, that's where you are.
Broadcast on the internet.
Well, there's nothing illegal.
12 hours later when the
As
machine's
long as
set
you're
up
only
perfectly
unlocking
and
your
it's ready
own
to
car
go.
with friends. Be a great sector asset. Oh, I locked my keys in my car. Hold on. Jam this in there.
Yeah, exactly. Give us a week. Figure it out eventually.
Code's kind of buggy.
Yeah.
A link or slide.
I know they show a video of pulling in Rhino file, so I don't know whether that code there was because there's a test 3D and a test 2D, and then there's another code that I think is actually a text document. It's just .txt. It's not a PDE. But I think if you launch that, that's the actual other programs.
Yeah, that's what I'm saying.
Okay. Never mind. Sounds like the 3D code currently is an array of 3 numbers, so maybe it's not as fancy as we'd like, but they do show a fancy Rhino script to bend thing in the video, so.
Well, if they're doing math, if you're providing them points in space and they're doing math on all the bends and stuff, it shouldn't be too hard to extract that from a
Yeah.
you know, any sort of STL or 3D.
I've tried swearing at it, and it works.
You got to kick it, Chris.
Oh, that's right. It's
That's
like
official technical support reply.
All right. So the other thing is this ball up here. Jim, what kind of ball is that?
That's a stellation of an Akasa heater.
There you go.
The second stellation.
It's a second stellation.
So I think stellation is just, it's a word like a stellar. I think it's the same word.
I'm sure
It's just
Shira's watching. She's going to hear it loud and proud.
You know what? Guess who actually knew what that was? Just looked at it and said, oh, that's a...
Shira?
No,
Oh,
Kate.
Kate.
She walked in, she goes, oh, that's it. And she knew that. That's pretty damn good. So it's basically, it's a 20-sided die. And then by making each face on that die a pointy pyramid, you wind up with a 60 face. So all the facets are the same and all the angles are the same?
What's the umbilical for?
Oh, that's the next part. So
The only thing I care about is
Oh,
the
Lord.
real donations are one of these days. So, oh, I didn't plug it in.
Uh-oh. Demo.
Oh, that's not good. Hang on, I'll be back. Jim, keep entertaining.
All right, so if anybody has any dollar bills, we need a couple. You in the audience with dollar bills?
Is this like a buckyball?
No, that'd be a 60-sided. It's a different shape. This is